the main thing I wanted to go through with this is the bearing stuff. All right. So we've got Peter, Alex, Mary. We've got Peter is 430 meters, and the important thing here is we say it's from Alex, okay, on a bearing of 113 degrees, and then equally, Mary is on a bearing again from Alex on a bearing of 210. So when you've got bearings, it's that from, that's your starting point. So basically, if you imagine what we're now looking at, is imagine Alex is the focal point, and those two, Peter and Mary, are away from Alex, and Alex is the main thing. So the question is, do you know what it's like? What would a diagram look like if Peter is on just a bearing of 113 from Alex? Would you know how to draw that diagram? Yeah? Everyone? Okay, so first off then, what are the rules for bearings?
They're always from the same initial angle. Like
Which
zero
is?
Zero. It's always the same.
But where's that from? What's zero?
The initial point.
Okay.
Alex.
The art?
Bearings, it always starts from the same point. How would I, in real life, have a consistent starting point? Where would I start from? Or what if Alex isn't in the situation? You know, just like in general, I'm talking about bearings. So yeah, I need to be consistently starting from zero. But the important thing is, where is zero?
The origin.
But I can be, let's say this bucket is my origin. Where is 90 degrees? Okay, well, what is it? So it's north, right? So we always measure from north. So for instance, I am going to put a dot to represent Alex, and arbitrarily I'm going to make north straight up. Right, so bearings are measured, like you were saying, from 0 degrees. 0 degrees is north. Right? So if you're on a map or something, we've actually got a specific map in front of us, then we would measure where north is, and then if you're told we're on a bearing of 65 degrees, you start north and you move 65 degrees. But what's the problem with that? We need a second rule for bearings. Because if I face north, yeah, which direction? Because if I do 65 degrees from north, I could be that way, or I could be somewhere else completely, yeah? So do you know what the second rule is? So we measure from north, and we measure clockwise. So what that means is that Peter is on a bearing of 113, so we start from north and we turn, right? Will that do? So my 113 degrees is like that, and this line is 430 meters, and that is where Peter is. Now, so this is a rough sketch. It's good that I should know what 113 is, so I get roughly the right place, but it doesn't matter because we're calculating values, we're not measuring. We could do this measuring perfectly on a map to scale and everything and work it out, so that's so useful. Now Mary is on a bearing of 210, again from Alex. Right? So we go back north from Alex and we go round, tell me when to stop. Okay, a little bit less, but remember it was definitely clockwise, and that would be the 210 degrees. This would be Mary. Right. And then the final question is find the distance between Peter and Mary. So we don't need a bearing, which would be another question, but we do need a distance. So I know that that is 310 meters. Okay. Now I can't make any judgments about what type of triangle that is because I've drawn nothing to scale. So please don't look at that. Oh, 90-degree angles. Looks like it. But we do have a triangle, right? If that's a, well, what do I know about the triangle? Well, I've got 310, 430. Do I know any of the angles in the triangle?
Yes.
Which one? Top one. Okay. What is that angle?
97.
Right. So it would be 210 minus the 130. Okay. So we've got 97 degrees. So that's that angle there. So if I want to know this distance here, MP. Right. I call it something else. So I call that. That's A up there. I'll call that A. That M, that P. Right, how do I figure out what angle? Why cosine rule?
Because you don't have any direct side and that angle.
Yeah. So we want to know, we know that angle, we want to know that, but we don't know a side with its opposite angle. So we've not got enough information for sine rule. So the cosine rule would be a squared equals, I don't have any B's and C's by the way, so what would it be in this case? Yeah. Yeah. So the only thing there different was the fact that we had to work out what that angle was in the triangle first. Bearings again. We can put those values in. So over to you to work that out in the calculator. Right.
You didn't see it.
Now I can chuck it all into my calculator in one go and get that, but if you need to do it in parts, remember, obviously all the multiplication gets done, then you do the addition and subtraction, don't get it wrong in that way. So what are bearings again? Measured from? Okay, now if I said to you, would it now be possible, it's not in the question, but would it be possible for you to work out the bearing of Mary from Peter?
Yes.
What would that look like on my diagram? The bearing of Mary from Peter.
We have a line north of Peter.
So Mary from Peter would be, I'd have to stick a north line at Peter, and then I need to know that. So that is Mary from Peter. So, what would I know? Anything already? Sorry, let me yeah, so remember I was saying quite often these questions, it's kind of a multiple, you use cosine rule and then you use sine rule, right? But let's have a look at this. So what did we say? A was 559.9, so we can round that to 560. Okay. All right, so we want to know this bearing. Now, what do I already know? Well, I can know this one. How do I know that? but it's not. This is where other things come into play. So this is your north line. This is another north line. This is a, what's it called? When you've got a line that crosses two other lines. T. Transversal. Okay, and what have I just basically got? I've got angles in parallel lines, right? And interior, inside parallel lines, that's 113. This must add up to 180, yeah? So we can do 180 minus the 113, I get. So that's that. Okay. So this one, the bearing, will be 360 degrees minus the 67, but minus also this angle in here. Alright? So minus that one. So how do I figure out that angle within in the triangle? So will that be sine rule now? Yeah. Would it be sine rule? Would it be cosine rule? Would it matter? Could I use cosine rule to work it out? Could I use sine rule to work it out? I'm going to ask you then, boys, we're going to do cosine rule, sine rule in the front. So you're going to work out this line, you are going to work out question mark using sine rule. Back row, you're going to use cosine rule. And see if we come up with the same answer. Let me know if there are any problems. So, I've got cosine rule written and sine rule written. Do you, without working it out, can you confirm that you have same things? So this one will then leave with sine of P equals 310 sine 97 divided by 560. Right. And if you do both of those, back row, cosine rule, what did you work out? You've got to do the inverse cosine, and this one the inverse sine. What do we get for the angle P for each one? Still working it through, but opposite way. What? The incorrect? Because opposite to correct would be 33.328,959, whatever. So rounding that to 33.3 degrees. That's why I use the sine rule. You concur cosine rules? Yeah. So you can see how we can use our sine and cosine rules to work out bearings. Yeah. Right. Next thing for you though is, like I said, it's a DP. It's a standard. So, standard level, you can see the kind of way it's written, the notation, what it looks like. So you've got, just from our topic, you can see why it's an important one. Find the length, find the size of an angle, calculate the area of the triangle, okay? And then determine whether the rope, so that's kind of an interpretation thing, that's quite a long 5 marks. But you should be able to do A, B and C pretty simply now. 10 marks.
In Harvard, I think that it's a pyramid. This is the
Oh,
way
you
that-
see it 3 dimensions, yeah.
Yeah, it's really hard to not see it like that. I can't.
It's not 3 dimensions. Pariah. It's my second. When we have these non-right angle triangles, we've got 2 rules. We've got cosine rule, we've got sine rule. The one that we used here, this is the cosine rule, which we wrote down. This is sine rule. Now, the thing about sine rule is you need to know an angle and its opposite side. You have to have a pair to use it. And in cosine rule, you have to have the angle in between 2 sides. So in this question, we don't actually have either at the moment because we know one side, but for cosine rule, you need to know at least 2 sides. And for sine rule, you must have at least a pair, right? And you must know the opposite side, angle or side to what you want to work out. So we've got a pair, so a side and its opposite angle. But if this is the side I want to know, I need to know that angle, and I don't yet, but you've already worked out that this angle will be 180 minus 72, also minus 55. What do you work that out? 53. So now, sine rule states that if we've got an angle and its opposite sides, and you've got an angle and you want to know its opposite side, which is what we want to know, we can write it's always a common ratio. So we went through this in the lesson. So sine rule states that put what you want to know on the top, so the question mark divided by, because it's sine rule, the sine of 53. That will equal the other side. It must be sides on top or angles on top. Can't mix the two up. So 70 over the sine of